Okay. This is Unit 5, Lesson 9. Integers are the set of whole numbers and their. Who's got an answer for me? Who can raise their hand and give me an answer? Gabby, what do you think it is? Integers are the set of whole numbers and their. Take a guess. Right here, the warm-up. Chin, you got an answer?
Well, integers are negative.
You're on the right track. Can somebody help out Chin? Go ahead. Nice. Integers are the set of whole numbers and their opposites. Got it? Okay. Now, you're going to compare these numbers using the inequality less than, greater than, and then the equal sign. So, first one, who's got this one? Tata?
The
0 is less than negative 2. Think about the number line.
Negative 2 is less than 0.
Right, but we need to flip it around because this is the order they gave it to us.
0 is more than negative 2.
Right, more than, but with the symbol that we use for more than is greater than. Okay? All right, who's got this one over here? Who can answer this one? All the way in the back. Nima, go ahead.
Equal.
You think these are equal? So if you have 14 and you owe 14, that's equal? Let's get that. You're not the first one to say that. Students this morning did the same thing. Think about the number line where these two sit on the number line. If you need to, look at my number line on the wall and compare the two. Jaden, what's the answer?
14 is greater than
14 is greater than negative 14. Do you guys see those two numbers on the number line? And notice negative 14 is in the negative side. It's all the way to the left. And positive 14 is in the blue region. It's on the right. And so the furthest one to the left is smaller. Who's got this one over here? Who can give me this one? Joel, what's this going to be? What's that? Well, you got to use one of these three symbols.
negative 4 is less than 5.
Very good. Okay, and who's got this one right here? Jakari, go ahead. Nice. Negative 17 is greater than negative 18. Okay, let's move right along. I'm going to go ahead and read this because since I'm going to be making a video from this. What you'll learn, graph and write algebraic inequalities. New vocabulary, inequality, solution of an inequality. Why learn this? When you use an expression such as at least or at most, you are talking about an inequality. You can use inequalities to represent situations that involve minimum or maximum amounts. A mathematical sentence that contains, this is a typo. Let me fix this really quickly. A mathematical sentence that contains less than, greater than, less than or equal to, greater than or equal to, or not equal to is an inequality. Sometimes an inequality contains a variable as in x greater than or equal to 2. Now, a solution of an inequality is any value that makes the inequality true. For example, 6, 8, and 15 are solutions to the inequality x greater than or equal to 6. However, 3, negative 2, and 0 are not solutions to that inequality. So let's take a look at why. Let's look at this number line. And I'm using this to kind of tie into the next lesson. So take a look. To test out if it's true or not, take the inequality and substitute for the inequality. So for this one, I'm going to plug in 6 into my inequality. This is what I get back. Is that true? Is 6 greater than or equal to 6? Yeah. That is true. And if you look over here, do you see this is the graph of x greater than or equal to 6. So at 6 we have a dot, and because it's greater than, I shade everything to the right of 6. Do you guys see that? Okay. Now, I'm going to graph 6, the point 6. Well, here it is in blue. And notice it's on the red of my graph for the inequality x greater than or equal to 6. Do you guys see that? It's on the red portion of the graph. So that is a solution. Now, 8 greater than or equal to 6. Is that true, class? Is that true? Yep, that's true also. And if you notice, I'm going to go ahead and plot that point. Here's 8. Notice it's in the red portion of my graph of the inequality. So that's true. Take a look at this. Can somebody raise their hand and tell me if this is true or false? Noah. right? Well, when you say farther than 6, do you mean further to the right of 6? It's to the right of 6. So 15 is to the right of 6, and it's in the red region of my graph. That is true also. Does that make sense? Now let's take a look at some examples that were not solutions. So here I have 3 for x, and is this true? No, 3 is not greater than or equal to 6. That's false. If you look down here, when I plot that on the graph, 3 is right here. Notice it's not on the red region. Do you guys see that? It's not a solution. And so if I substitute for x, -2, is that true? No. If I put this down here, here's -2. Again, it's not in the red region of the graph, so that is false. Khadijah, please put that away. And then the last one, 0. Here's 0. Is it in the red region? No. Okay, and clearly it's not greater than 6. That is also false. So you see we have our solutions to the equation, the inequality. These are my solutions. These are not solutions. These make my inequality true. These make my inequality false. Do you guys understand? Okay. Now let's go ahead and walk through this. Take a look at this. Find whether each number is a solution for this inequality. Can you guys really quickly on your own determine which ones are solutions? So just like I showed you on the last example, you're going to substitute and tell me if it's true or false. So really quickly, write these out, substitute, tell me if it's true or false. Then I'm going to show you the graph. Now when you take this quiz next week, they're going to expect you to know how to graph these, know how to solve these. So try and work these out. Nicole. Yeah, no, there's no fractions here. So can I get somebody to tell me whether or not the first value, is that going to be true or not? Khadijah? This is true. -3 is less than a +2. That's true. Okay. Who's got this one? Can I get a volunteer for this one? Miranda, is 0 less than 2? Yes, that's true. That is also a solution. Okay. And what about the next one? Who's got this one right here? 2. Mason?
It's true.
That is true. 2 is less than or equal to. That bar underneath it means that it can be equal to and then also anything less than. Okay? And then over here, the last problem. Who's got this one? Bryce. Is that true or false? So it's not a solution. Very good. So here are the solutions. -3, 0, and 2 are solutions to the inequality x is less than or equal to 2. Any questions about that? Now let me show you the graph. There's the graph. If you notice, there is only one point that wasn't in the red region for the graph x less than or equal to 2. If x is less than or equal to 2, that means it can be equal to 2. So there's a closed circle on 2, and we shade everything to the left of 2. Do you guys understand? Okay, that should be a review. I'm going to give you some more examples because we're going to be needing to graph these for ourselves here in a little bit. Okay, one more example. Which numbers of the inequality m greater than or equal to -3 are solutions? So test those out. Okay, who wants to walk me through the first value that we substitute? -3 greater than or equal to -3. Who's got that? Jeffrey, what do you got? I mean, Jameson, what do you got? True or false? Now, do you see the bar underneath it? That means it's greater than or equal to. So that bar, whenever you see that underneath that, that means it can also equal it. Okay? So it's true. And we actually graph those a little differently than the other type of inequalities that we saw earlier. So how about this one? Who's got this one? Miranda, go ahead. That's false. -8 is not greater than or equal to -3. Okay, and who's got this one? Tata?
It's true.
True, very good. And then the last one? Chin. True or false? You think that's false? Let's take a look at the number line. Hold on. Shh, 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 shh. Pause. Look, look, look. Right here. Here's my graph. If I say I'm equal to, I put a closed circle at that point, -3. Do you understand that? Closed circle. Okay? And then greater than means I shade everything to the right of that closed circle. Now, for the first example, the one that Jameson did, -3 sits right on top of that closed circle, so that is a solution. It's over the red region, right? We saw, I think this was Miranda. Miranda, you did this one? Okay. -8, do you see where -8 is? It's not anywhere near the red region that we shaded for the inequality. Do you understand? Okay, and then -2, who did -2? Tata. Here's -2 right here, and that's still in the red region for the graph, right? Now you got 1.4. Notice 1.4, it's a positive 1.4. Here's 0, here's 1, and 1.4 is almost a halfway to 2, right? So here it is. You see that's on the graph, so that one's actually true. Okay, are we good? And so our solutions are -3, -2, and 1 and 4/10. Yep.
How do you determine whether you go right or left on the number line?
Okay, so whatever is greater than that, pick out a number, right? Any number that's greater than -3. So -3, what are some numbers greater than -3? Any number. 10. 10 would be somewhere over here, right? So that means you would shade everything to that direction. Does that make sense? So I guess what I'm trying to get you to identify, just pick out any number that's going to be on the right or the left-hand side, or that's going to make it true, and say, okay, I need to shade that way. Okay? Uh-huh.
The arrow, the side of the arrow is pointing to the right.
Yeah, that means that means everything, anything going that direction for infinite. If I put 1,000,000, that would be a solution. Do you understand? Right. What's that? Oh, but this is just the number line this way. We have negative numbers this way. Is that what you're talking about? I'm sorry, I'm misunderstanding your question. Could you?
But it was just saying that there's another way to tell the that the equal or greater than
Uh-huh.
-3. The other way that the alligator mouth is pointing shape
What if I had -3 is less than or equal to m? Because that means the same thing, right? So I like picking a value and then shading in the direction of the value that makes it true. That's always going to get you there. Okay? All right. Any other questions? We're going to see some more. Here's what's up next. Now I need you to graph these. Can you guys take a look at these inequalities? Okay, so let me recap what I said. A graph can show all numbers in a solution. You can use closed circles and open circles to show whether numbers are included in the solution. So some of these inequalities will have a closed circle, some will have an open circle. So take a guess, see if you know how to do this. It should be review, but if it's not, here's a good opportunity to see if you remember it or to learn it. Try it. My first one is n greater than or equal to -3. Robert, can you explain what that graph's going to look like?
Okay, so you find -3.
Okay, yep, find -3. Here's -3, then what?
It says it's graded. The arrow is going to go to towards the positive
It's going to go to the right, yep. So we're going to shade to the right of -3, but what goes at -3? Solid circle, closed circle, because it says equal, that means it can equal -3. So here's what the graph looks like. Do you guys understand the graph? It's a closed circle at -3 because it can be -3. When you have a bar underneath the inequality, that means it can be that point at -3. It's greater than or equal to -3. Okay? Bryce, can you do the next one? Okay, so I'm finding 7. Here's 7. Is it open circle or closed circle? Open circle, very good. And which way am I going to shade? Very good. I'm going to shade to the left. Now, open circle means I can get really, really close to 7, but I'm not going to be 7. So 6.9, isn't that really close to 7? And it's still less than 7, right? But on a number line, that's going to look like it's 7. So how do we show that? We show that by putting an open circle there. That open circle means I can get really, really close to 7, but I can't be 7. Do you guys understand? Okay. Now, we've seen a couple. Let's go ahead and do this one. Let's see a couple more. Let's do one more. Who's got this one? Somebody I haven't heard from in a while. Nima, go ahead. Okay, I find -3. Here it is. Then what? Open circle. Open circle. Can you tell the class, because somebody just asked, how do I know if it's an open circle or closed circle? Can you explain how you know if it's an open circle or closed circle?
If it's open, it's a regular greater than or less than.
And then if it's closed?
It has a less than or equal to.
A less than or equal to or a greater than or equal to. Those are always closed circles. Okay? If it's just a less than or if it's just a greater than, open circle. If it's less than or equal to or greater than or equal to, that little bar underneath the inequality, that means you put closed circle. So you see up here, for this one right here, it was greater than or equal to closed circle. This one, it's not got it, it's just a regular less than, so open circle. So this one right here, like Nima was saying, it's a regular inequality. It's less than, okay? So it's gonna be open circle, and you set at -3. Now Nima, am I gonna shade to the right or the left? Which way am I gonna shade it in red? Well, if I shade to the right, then I'm saying everything bigger than -3 is a solution. Is that right? Okay. So pick something on the right of -3. What's a number on the right of -3? Any number. If I pick 2, if I put 2 in there, does that solve it? Is that a solution? No, so I'm not shading that way. Now pick something on the left side of -3. Any number. -6. Does that make it true? So that's the way we shade. You see how that works? Okay, are we good? Question, yes?
So if it's greater than, then you go to the left. If it's less than, then you go to the right.
Now, we have to be careful because sometimes they rearrange the order that the variable is going to be on. Does that make sense? So don't go by that. Pick a number, plug it in, see which way it's true. Because if they rewrite this, if they have -3 greater than W, then that might throw things off, okay? Yes, it will. But we're going to see a lot of practice today, okay? So move along. Now what I want you guys to do, go ahead. Now you have the graph. Now you need to write the inequality. So now we're going the other way. So earlier we had the inequality, you drew the graph. Now the graph is drawn for you. Now you need to give me the inequality. Okay, I still see a few people writing. When you're done, put your pencils down so we can talk about it. Who wants to share with the class what they think this first one's going to be? Somebody I haven't heard from. Carlos, what do you think this first graph's going to be? So the open circle tells us what? it can be one of two. Which ones could it be when it's open circle? So if we see an open circle, we know it can be one inequality or another. There's only two inequalities it could be, right? Can somebody tell them which ones do you know which one it can be if it's an open circle? Who can help him out? Robert, which two could it be if it's an open circle?
So if it's open circle, it can only be greater or less than.
So if it's an open circle, Carlos, it can either be a greater than or a less than, okay? And we have an open circle, so it's got to be a greater than or less than. Now, we got to figure out, name a variable. You said m? Okay, so m, now we got to say m is either greater than or less than something. But pick everything in the red region. See everything in red over here? Pick any of those numbers on the red side. 6. Okay, so m is greater than or equal to greater than 6 or less than 6? So I'm sorry, 2. Sorry, we have a 2. So here's what we're going to do. Yikes. Let me see if I can write this. So you said m. Sorry, let me take a quick timeout so I can add something. All right. All right. Okay, so m, you gave me m, right? We have our open circle at 2. So now we know this is either going to be greater than or less than because it's an open circle, right? We have to figure out which ones it's going to be. You said, hey, I see a 6 here. So if I replace 6 with m, what would my inequality be if I put a 6 there? Right, so I would use greater than, not less than, because 6 is greater than 2. Do you guys understand? Does that make sense? Isn't 6 greater than 2? So my inequality is going to be greater than 2. Do you guys understand how we test that out? Now I'm going to go ahead and do another one. Okay? Let's take a look at this next one. And let's walk through this next one. Okay, write an inequality for this. First of all, we see an open circle. So class, which 2 can it be? It's either a greater than or less than, right? So we already know it's got to be either a greater than or it's going to be a less than, right? And pick out a variable. Can you pick out a variable? Pick out a variable, Jaden. J for Jaden. Okay, we're going to pick J for Jaden. And now, look at where my open circle is at. Where is it at, ladies and gentlemen?
4.
It's at 4. So if it's at 4, we need to figure out what number we're going to use here. Now, pick a number that's in the red region. Any of those numbers. Pick any of those numbers. Which one do you want to pick out? I heard -4. So somebody said -4. So we'll pick -4. So instead of J, I'm going to put -4 here. So I'm replacing J with -4. So if I put -4 there, which inequality would I use? Is that greater than or is that less than 4? Less than 4. So guess what? Since I took that from the side that's in the red region, I could say J is less than 4. Are we good? Okay. So I used X. Jaden used J. We know why Jaden used J. Any questions about that? Do you guys understand how to go about this now? Okay. So when I get to the next lesson, you're going to really understand why we graph the way we do. All right. So let's take a look at this. I'm going to read the first problem to you. You can write an inequality to describe real-world situations, application, nutrition. To be labeled sugar-free, a product must contain less than 5 grams of sugar per serving. So you can they can label something sugar-free, and there can still be sugar in it, but it just can't be more than half a gram per serving, okay? So we need to write an inequality to describe this requirement. So I'm going to go ahead and do this one. I'm going to let you guys do the next one. Okay, so first of all, the amount of sugar is less than 5 grams. Well, that's to be sugar-free, right? I'm going to come up with a variable, just like Jaden used J for the last one. I'm going to use S for sugar. Let S, the number of grams of sugar in a serving of food. Are we good? Okay, and then it's pretty easy from then on out. Take a look. S has got to be less than 0.5 or 5/10. That's the inequality. Easy? All right, can you guys do this one now? Write an inequality for the word phrase. To qualify for the race, your time can be at most 62 seconds. At most 62 seconds. Go ahead and try, see if you get it right. These are the word problems. This is where a lot of you guys struggle. So this is where you guys should really see if you comprehend what the words are saying. And then I'd love to have a volunteer explain or give me their guess. Jeffrey, what's your guess? What do you think it's going to be?
Less than 62.
Okay, let's see what we got here. We got our race time. It's at most. And what did you say was your inequality?
Less than.
Okay, at most. Think about that.
Less than equal to.
Okay, at most means it can be up to 60 seconds.
But it can't be greater than.
Well, you're trying to qualify for a race, right? So if you take too long, they're not going to let you race. Does that make sense?
Yes.
Okay, so here's what it is. Your time is got to be less than or equal to 62 seconds. If it's more than 62, sorry, you didn't make it to the group. Okay, so here's your inequality. T is less than or equal to 62. 62.5, isn't that greater than 62? So you're out. Sorry. Half a second too slow. You get a watch from the stands. Now, take a look. What is the name of a mathematical sentence that contains the symbols less than, greater than, less than or equal to, greater than or equal to, or not equal to? So, Marcellus, what do we call a mathematical sentence that has these symbols? Shh. Nicole, what do we call a mathematical sentence that has these symbols in it? An inequality. Now, take a look at this. Is -4 greater than or equal to 4? Who has this? Who can explain this answer to me? Michaela.
-4 is farther from 0, and +4 is closer to it.
Now, actually, -4 and +4 are the same distance from 0, right? But one is further to the left, right? Which one's further to the left? -4. So what's that mean about -4 and 4? They're not equal, but on the number line, if you're further left, what does that mean? Can somebody help her out? On a number line, if you're further to the left, what does that mean? Go ahead. It's smaller. It's smaller. So if you're farther left than another point, it's smaller. So here's the explanation. No, -4 is left to 4 on the number line, and -4 is less than +4. Okay? Now look, which inequality does not have 8 as a solution? So now notice, all these inequalities are different. But they're saying, hey, which one's does not have 8 as a solution? So for y, we're going to replace all of those with 8. And now we're going to figure out which one does not have 8 as a solution. First of all, if I replace 8 here, is this true or false? -3, isn't that less than +8? Shh, that's true. Is this true or false? Isn't 13 greater than or equal to 8? That's true. Is 8 less than 8? That is false. Is 8 greater than or equal to 8? That is true. So the one that 8 is not a solution is this inequality right here. Any question? Okay, now, we did this earlier. Which numbers are solutions for the inequality? So they gave you the inequality, and they gave you some numbers to test. So let's go ahead and test the first set of numbers. Is this true? -6, is that greater than -5?
Yeah.
No.
That's false. Think about number line. That's farther to the left. -1, is that greater than -5?
Yes.
That is true. 0, is that greater than -5?
True.
That is true. So my solutions are -1 and 0. Those are solutions to that inequality. So let's just test this next inequality. So here we go. I'm going to replace my x with my values. Is this first inequality, when I substitute -1 for x, is that true or false?
True.
That is true. What about this one? Is +1 less than or equal to -1? That is false. What about 3? Is 3 less than or equal to -1? That is false also. So my solution, I only have one solution. It's -1 is a solution of x less than or equal to -1. Last one for this lesson. Here we go. I replaced into this inequality these values. Is -1 greater than 0? False. Is 0 greater than 0? False. Is 1 greater than 0? True. So my solution is 1 for that inequality. Okay, are we good?
Yes.
All right.